Hello. So this is our project predicting forest wildfires using various factors and machine learning. So it's by me, Sarvagya Goyal, Romir Hiremath, Janaki Venkatesh, and Ridhima Morampudi. And our advisor is Dr. Subramanian.
Oh, sorry, I
Romir,
was muted. But our background is that fires are really prevalent in today's world. They have like the ability to destroy homes and start wildfires. So we decided that we'd actually do something about it using research. So we used machine learning, and then we came up with a machine learning model that accurately predicts whether there's going to be a fire or not. And then our problem statement is predicting whether there's going to be a fire in a certain area using various factors such as humidity, temperature, and factors from the Canadian Wildfire Fire Information System. So how we collected data is that we searched and used data from various national parks, including Montesino Natural Park in Portugal, northeast of Algeria, and Sidi Belabis region located in northwest of Algeria. And when finding the data sets, we looked for the same or similar factors. And in the pictures on the one in the left and the one in the right, as you could see, the factors are really similar. So that's what we looked for when we were searching for data sets.
So how we processed our data was our data collection, when we collected it, it consisted mainly of numbers. So this made our data processing quite easy, but we did have a few problems. So one of our output was to predict whether there's going to be a fire or not. And in our data, that consisted of words. So what we did is we just simply in an Excel sheet, we changed every not fire into a 0 and fire into a 1, so that when we actually run our model, we would get a 0 or 1 output, making our code much better. And we also had a few holes in our numerical data. For example, we had a hole in our FFMC, as you can see in the graph over in the bottom. So what we did to fix that is we took the mean of each column or like factor, such as like taking the mean of every value in FFMC and plugging that mean into the empty data values. And this helped our code and machine learning model not have any errors and be more accurate. And if you want to see some number only data, it's at the bottom. These are all our factors. And then to the right is our output in word form, but we changed that to 0 and 1s later. And then how we built our model is using Google Collaboratory to code our model. And in this, we used Python. So some modules we used to code our model was pandas, NumPy, Seaborn, train test split from the sklearn.model underscore selection, tree from sklearn, and ensemble from sklearn. So what tree from sklearn was a very important random forest classifier we found that was crucial to building our training and testing data set, as that helped us make our data set and actually predict the values. And you can see to the right, these are just some examples of the code, how we inputted them and the syntax.
Okay, so we can accurately predict if a forest fire will occur based on the specific environment factors recorded at that area. So for example, not only the month, but also certain conditions such as Sarvagya explained, FFMC, which stands for Fine Fuel Moisture Code and represents the general moisture conditions in the area. Some other examples are DMC, which is a Duff Moisture Code, and it's a numeric rating of the average moisture content in loosely compacted organic layers. There's also ISI, which is the initial spread index, or how far the fire will spread, as well as various other general weather conditions such as wind and rain. So to test our model, we inputted various numerics that are similar to the data we trained with to accurately see if the model was able to detect the fire or not. And in the slide, you can see an example of how we were able to write that in the code. And then moreover, the main benefit that we want to and hope to extend to society through the usage of our classifier is to help with the distribution of firefighters in the case of numerous fires occurring, to see which one should be contaminated or attacked first. And in the future, speaking more technically, we would want to make our model more accurate by giving each column weight using the random forest classifier, or SMOT, for over and under sampling. And as a general addition, we also want to take into account the multiple locations and hemispheres that fires are more prone to as a factor of predicting when and where the fire would spread and occur. We'd also like to thank Dr. Subramanian for giving us guidance and helping us all throughout our project. So thank you for listening.